Hello guys, welcome back to the channel. So today I was solving this 114 div 3 contest. So let's see the solutions of it. Like we would be discussing D, C, C1 and B. Like A and B are very easy, so we'll just go through them. But we'll start from the D. Okay. So let's see the problem statement, what the problem is saying. So the problem is saying you are given with a secret array of n positive integers. Each element is given and the shadow of I is given. You need to construct the lexicographically smallest. Okay, so what the question is saying that you are given with some bi array, right? And this bi array is defined as sigma of I equal to 0 till n, like some j from 0 to n, such that for every a of j which is less than a of I, right, we are doing the summation of this. Let me explain you with the problem. Let's suppose we take this array. Okay, so we are given with an array b which is equals to 0 4 0 4 14 and its corresponding a array given is 2 5 2 5 and 6. So if we see, so let's suppose if we take a of 0, so elements less than this is none, right? So b of 0 is 0. If we take this, so the elements which are less than 5 are 2 and 2, so the sum would be 4. Now if we go to this, the elements less than 2 are 0, so the sum would also be 0. For this 5, it would still be 2 and 2, so 4. For this 6, we have 2 5 2 5, so it would be 14. So I'm sure you are able to understand the problem statement, right? Now let's see what does the, like, how do we actually solve this problem. Okay, now let's see the solution of it. You just need to visualize two things into this and then the problem would actually be solved. First of all, if we say the sorted order of B would equal to sorted order of A. Like if we sort the order of B and then we'll go and find the A, it would give me the sorted order of A, right? Now understand this particular thing. Let's suppose we have a group of identical values in A. Let's suppose initially we have v1 as the smallest value in this array A. Okay, we have v1 as the smallest value and the count of v1 is actually, let's define it as c1. Okay, the number of times v1 is coming is, let's define it as c1. So we know that b1 would always be 0. Like this is the base, like this is always be 0 because the first element is v1 is the smallest, so this particular b1 would always be 0. Now b2 would be equal to 0 plus v1 times c1, right? We can define b2 like this. Now if we try to deduce a formula from here, we can say that every v of I would be equal to b of I plus 1 minus b of I by c of I, right? We can say this, right? And there is always a condition that v of I is an integer, so c of I modulo this b of I plus 1 minus b of I should always be equal to 0. Like I'll write it as an opposite way, it should be opposite. Like we could say, simply say c of I should divide this diff. Let's define it as diff only. Then for each v of I you can define, like if you know these values you can easily find v of I, right? And you need to make the lexicographic order, right? You need to make the lexicographical order. So you can always say that v1 is less than v2. You can always find this and we can define some v of I is always equal to v of last, right? It would always be v of last plus 1, like, right? This we could always define, right? So this is how you have to like find, like you need to understand this, you need to just reduce this particular formula only and then you would be able to solve this problem. So if you see the solution for this, what I have done is, I have initialized a map where I've find the frequency, and then I've made an array which stores the unique elements, right? All of those unique elements. Now for all of those unique b of i's, if like first of all this is a base condition, we can say that b of a of 0 should be 0 only. Now we have find the diff and we have found the count. If the count is not divisible, then we know that it could not be possible. If it is there, then we'll find the current value. Okay, and if current value is less than the previous, then we can say it would always be -1, because we know that v1 is the smallest. Next, v2 should be greater than v1, okay, because we are dealing in the sorted fashion, right? So if this is not the case, then we are simply returning -1, else answer of a of i's will be current and previous would be changed to current, and then this is how we are outputting our final answer. I'm sure you will be able to understand how we are solving this D problem. Now let's move to the C2 problem. Like C1 and C2 are the same thing, so we'll be discussing C2 only. You need to just understand the logic behind it. Once you understand what the logic is, you can easily solve C1 problem. Okay, so yeah, let's see the C problem, what exactly the problem was saying. Okay, so if you read the problem statement carefully, what they are saying is that we have given with two strings. This could be changed to this, and 011. Okay, 011 could be changed to 110, right? So this we can change to this, right? And you are given with some a string, right? Some binary string, right? And some binary string b. You need to tell what are the minimum number of steps. Like in C1 you need to tell whether we could make C1 to C2, like a yes or a no, and in C2 you have to tell the minimum steps. Okay, so from C2 only you can say if the C2 is -1, your answer would be no. If like there would be some steps, your answer would be yes. Okay, so we'll be discussing C2 only. Okay, so if you see, let's see the observation first. Like what observation I have deduced while solving this problem is, if you see this particular C, when you are changing 0012 to 100, check this element. This is not being changed, right? And these elements are being changed to the opposite value. Okay, let's see for this also. 011 110. This middle value is not changed. This odd values are getting changed. So like this even values are getting changed and this odd values are at the same position, right? So can we say that I and I plus 2 are getting swapped, right? And I plus 1 always remain at its original position, right? So can we say that every even index can only move to the even index and every odd index could only move to the odd index, right? Just try to think this particular part. Once you will understand this particular part, the problem would be just a piece of cake. Now once you understand this particular logic, our problem actually reduced to just two separate subproblems. Okay, two separate subproblems is that one for even positions and one for odd positions, right? So if you are dealing with only even positions, when you are only dealing with even positions, you go and find all the ones position in A and in B, right? And similarly for zeros as well. And when you are moving some AIth to the BIth position, right, what it would be? It would simply be the summation of position of A of I minus position of B of I, like the absolute value. You can take the absolute value of position of A of I minus position of B of I, and this would always be by 2, like divided by 2, right? The reason we are dividing it by 2 is that because on one particular swap, you are dealing in two positions. Like this particular I has gone to I plus 2, and this particular, then this, if you take this particular case, then this would be done to I plus 2, right? So we are jumping by 2 positions, so our net would be divided by 2, right? So this is how you would be calculating the minimum number of operations. So for even you will find the operation, and for odd you will find the operation, simply add them up, you will get the answer. Right, now let me show you the code for this. So if you see the code, so what I've done is I've made a list of even arrays, odd indexes and even indexes. So what I've done is simply, like, if I by 2 is 0, well, if it's an even, then if a of I is equals to 1 position, I've simply divided the position by 2 only. So I've added this particular into different arrays. First of all, we need to understand that the sizes should be equal, like the count of ones and zeros in both of them should be same. After that, our simply answer would be just adding the absolute differences and putting the answer. So this is how you would be solving the C2 problem, and if your answer is -1, it would be no. If your answer is not -1, your answer would be yes. So you can easily solve C1 as well. Right, now let's see the B problem. Like, B problem is also very easy, I would say. You just need to understand one thing in the B problem is that, okay, so let's see. Okay, so if we say that so if you understand B, let me give you the analogy with an example. Okay, so let's like I'm sure that every one of you would be able to understand what the B problem is saying. So let's just jump to the cases. Right, so first of all, you can find the length, right? What is the original length? If we are not deleting any element from the string, you can easily find the length, like it would be the number of sections only, for which s of I is not equal to s of I plus 1. Simply do count plus plus, and plus 1 would be your length, right? This you can easily do. Now let's understand this particular case. So initially what it was contributing, let's suppose we have not deleted B, right? So initially if you see that this would be contributing as 2, right? So once we have deleted this B, the contribution of this would actually become 0, right? Like initially it would be this example and this, right? But after that the length would actually return to 0. So our difference is actually -2, because if we are removing B, then our distribution has to be done by -2. So it means the current length that we have, L, we need to do -2 from this, right? Now there are cases like we could have A, B, C, right, where the initial contribution is of 2 but final contribution is of 1. So here the reduction will be of -1. Or if it could be A and A, here the reduction would be of 0. So what we can do is, we know the original length, right? We could see that what reduction we have to do, like what is a minimum reduction, like the largest negative number that we could have, we could choose that one, and then we could simply add that largest negative number here, which we could define as delta, and this would actually give us the final answer, right? So this you can easily find, and this operation you would be doing is from 1 to n-1, because that only the numbers you would be like adding to the delta, right? So this is how you would be solving all of the problem. So if you like the solution to this A, B, C, D and all those this, so do like, share and subscribe the channel, guys. And like I'll be trying to solve more and more problems for you, and like would be soon bringing you the CSES playlist. I'm working on it, so it would be soon I would be giving you all of the solutions. Yeah, okay, thank you guys.